Hello and welcome back. Today we're going to look at bond valuation once again. Specifically, we're going to look at valuing a bond in between coupon payment dates. Before we look at the specific examples, I just wanted to spend a few minutes talking about the concepts behind the bond valuation techniques that we're going to use. When a bond is in between coupon payment dates, its price has two parts. There's the flat price and the accrued interest. From the time of the last payment, the rate of increase in the bond's value is equal to the bond's yield to maturity. So the value of this bond between coupon payment dates is its valuation at the last payment date multiplied by a future value factor. This future value factor is 1 plus the yield to maturity raised to small t, which is the number of days from the last coupon payment date until the date that the bond trade will settle, divided by capital T, which is the number of days between the last coupon date and the next coupon date. Now note that there are different conventions used in the bond markets to count days. The two most common day count conventions are actual and 30-360. For the actual method, the actual number of days is used, and for the 30-360, we assume each month has 30 days and that a full year has 360 days. Actual is most commonly used for government bonds, and 30-360 is often used on corporate bonds. So after adjusting the value of the bond at the last coupon payment date with this future value factor, we get what is known as the full price, also called the invoice price or dirty price of the bond. Now there's a second concept here called the accrued interest. The accrued interest since the last payment date can be calculated as the coupon payment times the portion of the coupon period that has passed between the last coupon payment date and the settlement date of the transaction. So the full price or invoice price minus the accrued interest is referred to as the flat price of the bond. This is also known as the clean or quoted price. Note that the calculation of accrued interest does not discount the accrued interest to its present value, so that the value of the bond on its last payment date plus the accrued interest is greater than the full price of the bond. The reason for using the flat price for quotation is to avoid misleading investors about the market price trend for the bond. If the full price were to be quoted by dealers, investors would see the price rise day after day, even if the yield to maturity did not change. Now that's because the amount of accrued interest increases each day. If the trade of the bond takes place, then the accrued interest is added to the flat price to obtain the full price paid by the buyer and received by the seller on the settlement date. So with those conventions clearly explained, let's look at a couple of examples. Okay, so in this case, we're given a corporate bond, we're given its coupon rate, its payment dates, maturity date, yield to maturity, and we're asked for the full price, and we're given a settlement date. So just to recall from this graphic, the first step is we're going to compute the present value as of the last coupon payment date of the bond, which was in March. Then we're going to adjust that number with a present value factor. Now, in terms of computing the present value, recall that there are two coupon payments in 2018, 2 in 2017, and 1 in 16. So that gives N as 5. The payments are the coupon payments, which are $4. The rate is given as 5% on a bond equivalent yield basis. So that's 2.5%. And the future value, of course, is 100. So if we plug all this in, we get our present value as 106.97. Now the next step, of course, is to adjust this with the period adjustment by multiplying it with the period adjustment factor, which is 1.025, raised to the number of days. Now note that there are 2 months and 2 days that have elapsed since the last payment. So based on the 30-360 day convention, that's 62 days of 180. We put this into our calculator and we get the total dirty, full, or invoice price as 107.88, which would make B the correct answer. So you can see, once you have the graphic in mind, breaking down the problem into its component parts becomes a whole lot easier. Let's look at another problem. Now in this case, we're given a US Treasury note, we're given the coupon rate and the days to the next payment, and we're given the quoted price. Now if we recall our graphic, we realize that the clean or flat or quoted price all refer to the same number. And in fact, we're given the quoted price, which is 96.889 on a $1,000 face value bond. So we're given the answer, we just have to convert this. And of course that becomes 968.89, which is closest to 969. So B is the correct answer. I hope you found this graphic that I've created useful. I wish you all the best in your preparation, and I will see you soon with more videos.